Today we're going to explain the thermal protections or overload protections. It's composed by Clayderman, Agudelo, Gonzalez, and me, Michael Gòmez. Okay, now I am going to explain what it works, how it works. Okay. Okay, the tripolar thermal relays have three bilaminar, each composed of two metals with coefficients of different expansions, joined by bilaminars and supported by the heading winding. Each heading winding is connected in series to the bases of the motor. The current absorbed by the motor hits the winding, causing the bilaminates to deform to a greater or lesser degree depending on the intensity of the current. Okay? The deformation of the bilaminar causes the rotatory movement of a cam or a shaft attached to a firing device, I think so. If the current absorbed by the receiver exceeds the value of settings of the relay, the bilaminates will be deformed enough that the bottom to which the bars are attached to the contacts is for the clamping stop. Okay, that produces that all the circuit stops. This movement causes a broad relay contact, like I said, inserted in the current of the contactor and closing of the second contact. Reset will not be possible until the bilaminar code occurs. Okay, this protection against overloads is the most common failures in machines are overloads, of course, so we use it, which manifests themselves through an increasing current absorbed by the motor and certain thermal effects. Every time that the limit temperature is exceeded operation, the insulator wear out prematurely, shortening its useful life. For example, when the operation temperature of an engine is permanently exceeds 10 degrees, for example, defined by the time of insulation, the useful life of the engine is reduced by 15% more or less, I think so. It should be noted, however, that when excessive heating as a result of overload, the negative effects are not immediate, provided that it has a limited duration and is not repeated very often. Therefore, it doesn't necessarily stop the engine. However, it's important to quickly recover the condition of normal operation. The correct protection against overloads is essential, for example, for optimize the durability of a motor, guarantee the continuity of exploration of a machine, and restart after a shot with a faster and better security. And that's it.
I am gonna continue with the relay parts. Bueno, sector manual racing means that upper inversion should, as pressing a button is required to reset the motor. Set to reset allows the motor to reset automatically, close contact with terminal marks and number 95, 96. Also as normal open contact 97 and 98. That is case of trip-while close and can be used for a pilot light on alarm to indicate that the motor was driven by an overload. Of course, is as three input and power contact to connect the motor to the output and the contact to the thermal input is also as is also a stop boot in case we come to test the terminal or open the circuit to stop the engine for any circumstance.
Now, I am going to explain the direct start. A direct start is the easier form to start a motor. A direct start is composed by a thermomagnetic protection or breaker, contactor, and thermal relay. The thermal relay is located to under the contactor because the thermal relay must protect to circuit of control and circuit of power. When the overload is produced, the thermal relay opens the circuit of power, and also the thermal relay open the circuit of control. Now I am gonna to explain a little example to operation. Here we have a start switch and stop switch. When we press to switch, the contactor is activated. When the overload is produced, the thermal relay open the circuit, the power, and close the circuit of control.
And that's it. It's that like it works.